Good afternoon to everyone. Myself, Salji, pursuing BTech in AIML at GM University. Today, we are presenting the assignment one of software engineering practices with agile methodologies. And my topic is about apply solid design principles to AI model development. And our guide is Mr. Praveen Sir, Assistant Professor AIML Department. Introduction. AI software today is very large and complex. If you don't design it properly, the code becomes messy. One small change can break many other parts. To avoid these, software engineers use solid design principles like which were introduced by Robert Seaman, also known as Uncle Bob. By applying these principles, AI software becomes easier to maintain, scale, and improve over time. And the next slide, what are solid principles? Solid is a group of 5 rules that help developers write clean and organized code. They are SOLID. For S means single responsibility. One class does one job. O means open. Add a new features without changing existing code. L means list of substitutions. A child classes can replace parent classes without errors. I. Interface segregation. Don't force a class to do things it doesn't need. D. Dependencies in inversion. Depend on abstract class ideas, not specific code. These principles make the code reusable and easier to understand. A single responsibility principle SRP. A class model should have only one reason to change in AI. This means that each part of the code should have only one job. In AI, that could mean separating the code into different modules like one for data preprocessing, one for training the model, one for evaluating the result. When each file or class has one clear purpose, it is easier to make changes without breaking something else. And then in the next slide, open close principle OCP. This rule says that the software should be open for adding new features but closed for editing old code. For example, if you have already have a working AI model, you can able to add it without touching the existing code. That's why your system can grow and improve without causing bugs. A Liskov substitution principle LSP. This means that any child class should be able to replace its parent class and the system should still work properly. In AI terms, if all models like SVM, decision tree, and neural networks have the same functions like train, predict, then we can easily make the models simple. And the interface segregation principle ISP. This principle says we should not force a class to use methods if it doesn't need. For example, a visualization class that draws graph doesn't need turning function. So we create smaller specific interface instead of one big one. Dependencies inversion principle DIP. This rule means that high level code shouldn't depend directly on low level details. Instead of both interface for AI models, you can switch between TensorFlow and PyTorch without changing the rest of the code. This gives flexibility and speed in AI model design. Here, it explains that data model for collecting and sending and cleaning data, and this is the abstract of our this is the methodology of cleaning data model module for benefits of applying solid. When solid principles are used properly, we get many advantages like easy to maintain, easy to scale, better teamwork, easier testing, reusability, stable on integration. Easy to maintain means fix one part without touching others. Easy to scale means add new models easily. Better teamwork. Developers can work on different modules. Easier testing. You can test one part at a time. Reusability. Use same code in other projects. Stable integration. Less chances of errors when combining modules. Overall, it improves code quality and reduces long-term issues. And in the next slide, integration with agile methodologies. Agile development focuses on working in small steps like called sprints and improving continuously. A solid fits perfectly with agile methodologies. Each model can be planned as a separate user story. Different team members can work independently using Git. Continuous integration can automatically test each module. So solid plus agile is equal to faster and which is flexible and more reliable to AI development. And in the next slide, challenges and limitations. Although solid is useful, it's not perfect for every situation. It can cause over engineering if used for small projects. Too many classes and interfaces can make the system complex. Developers need strong coding skills to apply it correctly. Sometimes a few exceptions can reduce performance greatly. So its performance, it's so it is important to use solid wisely, especially when working on large and long-term AI projects. And in the next slide, conclusion. The final slide sums up everything. Each solid rule plays a role. Structured and sustainable approach to development system. XRP ensures clarity. OCP enables extension. LSP a consistent design. IFP efficiency. DIP flexibility. When used with agile methodologies and my agile methods, Solid helps developers build AI systems that are easy to update, maintain, and expand. It turns short AI experiment into real production level application that can grow with the time. And ultimately, the solid approaches bridges the gap between AI research and prototypes and production-ready AI system, paving the way of scalable, maintainable, and future-proof AI software solution. Thank you, sir.